Good afternoon, good morning, good evening to you guys, wherever you're sitting. And okay, we can, I guess we can start, Tino. So welcome. And let's start the presentation, Tino.
Okay.
So, all right.
Here we go.
Okay, so welcome to the GMI Safety Requirement Specification Seminar, webinar. As we have collected several questions during sign up, and we have a very busy schedule, so we'll try to get right to it. Let me do one thing here. Okay. So we can take control of the presentation for a few seconds.
Okay, you've got the control.
All right. So first of all, see if it works. Well, let's go to the next slide, Tino.
Okay.
Okay, I got it. Okay, first of all, let me introduce Tino, our speaker today. Tino has over 30 years of experience in the process industry and is a senior functional safety expert and trainer under the SRS TUV Rhineland program. He has published many papers and has run many seminars and training programs around the world. So he's more than qualified to be our speaker today. I will only take a few moments to introduce GMI, who we are and what we do and why we do it. So GMI, or GM International, it's a company designing, engineering, and manufacturing a complete range of intrinsically safe and seal certified devices for all automation packages, from DCS, fire and gas, to SCADA, in every industrial sector, from oil and gas to food and beverage. We have over 40 years of experience, and we are very proud to manufacture our product 100% here in our Italian headquarters. And however, we are a global player. And because we make safety product, we take special care to ensure that the best products are engineered and supplied. We have a motto, which is 100% customer satisfaction, while reducing the impact of the world we live in. Safer product for a safer environment, for more safety with people. And you can see, you know, we have full testing, we are SC3 compliant, so our factory is certified up to C3 for functional safety management. And these are the products we manufacture. So we go from IS barrier, safety relays, isolators, power supplies, multiplexers, a lot of custom termination boards, arc multiplexers, surge protection devices. We do loop indicators, and we have a division that runs functional safety training and services. Lately, not so many trainings due to this COVID, and we are introducing a division or an addition for EX training as well under the CompCX program. As I said, local company, but with the global outreach. We have 8 subsidiaries, many distributors. We are about 200 people in GMI, and we are used to run many courses. Last year, we did 18 courses for functional safety engineer. This year, so far, only 1 or 2, right, Tino? I don't remember now.
I think 2 for the moment.
But, you know, we are on hold because of this COVID, so we are running many webinars. And we do have thousands of installations around the world. This is some of our customers. We interface with all the system vendors from ABB to Yokogawa. We've done projects with most of the EPCs. And we have many OEMs to whom we supply our products, such as Schlumberger skids or General Electric gas turbine, and so on. And we are in the AVL of many end users globally. So before I give it out to you, Tino, let me mention a technical point. We have collected many questions from you guys already, which we will answer them at the end of the presentation. In the meantime, you have a box there, a question and answer box. You can ask questions throughout the presentation. We will try to get to them as we can, so during or after, but just don't forget, just ask any question you like, you know, of course, not what's up for dinner tonight, because I don't have any answer to that. Okay, Tino, it's up to you. Let me release control back to you.
Thank you very much, Paolo, for the introduction and giving us the opportunity to actually share some of the functional safety topics. As Paolo was mentioning today, the topic chosen is Safety Requirement Specification. It is actually the document that needs to explain exactly what should be built, how it should be maintained, and how you can prove that your safety loops are still, let's say, achieving the necessary risk reduction.
All right.
Okay, so I'm starting here with a slide which is called the safety life cycle, which is basically a model on how to work step per step with activities in the life cycle. I will try to move here with the mouse, which I think you could see here as a pointer. This is the first step in any project, and I will not go through all the steps, but basically, in a nutshell, you need to identify what hazards you have, you need to think about them, you need to analyze them, you need to find out what type of potential frequencies can be there, which is always a challenging, or let's say it's always a difficult topic to agree with. And then the other point, which is more easier, is what are the consequences of that hazard. So once you know that, you go here in this box number 2, which is called the allocation to existing layers. We call this, in our terminology, we call this LOPA, which means layers of protection analysis. In other words, you're going to put layers on top of each other. And those layers need to protect whatever's on the bottom, which is your production unit, enable to protect you to a certain risk reduction that you are tolerable or that you are allowed to live or to work in. And today's topic is, once you realize that your existing systems or existing control layers do not give you the necessary risk reduction, it's then time to define an additional safety loop, which we will call a safety implemented function. What should be actually being designed, maintained in the field in order to reduce that risk to an acceptable level. So, the audio explanation support, which I show here on the bottom, purely means that what I just explained you in phase 1, 2, 3, this is here written in text, because we will also share you later on with those slides, so then you can read this again and you can listen again to what we were saying. And I actually noticed that my colleague, oh, he's back, Paolo. So we have a poll.
I'm right here. I'm listening to you. I just don't want to take the scene away from you, so I'll let you speak. But also, it looks like we have a poll here. All right, so let's launch this poll. And, Tino, we already start getting questions. Let me remind you guys, the questions should be, relevant to what we are talking here. So, how do you value this? Oh, sorry.
No. This is the wrong poll, I think, Paolo.
Hey, gosh. Sorry, guys. I launched the wrong poll because I was trying to talk to Tino. So we are talking about the ownership of the SRS. So this is the right poll. Sorry, guys.
Correct. Now,
so what is the ownership of the SRS lies with the, okay, we have several answers. This is not an easy question. Safety consultant, engineering contractor, SRS integration team, end user or operating company, operation and maintenance team, main automation contractor, or all of the above. Well, you guys are voting. I don't know, Tino, if you see the votes coming or not.
Yeah, I see the votes coming in, and I saw participants, a huge number of participants, which is only 17%, only 40% of the participants has voted. So let's give it a few more minutes.
Yeah, and as I said, guys, you got the question. That's why I carried away earlier. You're posing question, but let's keep the question relating to the topic today. So SRS.
Correct. So maybe I give you some more of the background here on why this question comes up. The ownership itself of the document describing what risk reduction we try to achieve with our safety implemented system. Well, I think the poll is nearly finished. I see that we only have 50.
Okay. Let me end the poll then.
Okay.
And share the result.
All right. So.
All right, Tino.
Well, it's not surprising that not many people collect or select. The only correct answer in this story is here, the operating company / the end user. Okay, so that means any operating company, the plant management is responsible to maintain the safety in their production unit. Therefore, the document describing how to achieve this, the ownership of that document is clearly the operating company / the end user. It cannot be that some people will say, oh, I think it's a safety consultant who owns or who has the ownership of the SRS. So it's the end user.
Is the right answer.
And it's the operating company. Correct, Paolo. So all the other ones, it's certainly not all of the above. Okay? They can be responsible to define it and to create it, but the ownership of safety is always the operating company or the plant management. Okay, Paolo, thank you for the poll.
You're welcome.
All right. So
you can go on. And
general requirements.
In background.
Okay, thank you. So general requirements. What is now the general requirement? As you can imagine, we need to try to achieve a document which is so clear that anyone reading it can understand exactly what needs to be built. What needs to be built is the first step, but secondly also how to operate it and how to maintain it. It's also a ongoing, let's say, life document. It cannot be an SRS from the design phase, actually that was used to start up the plant, all of a sudden becomes a document which is out of date or not being kept up to date. In other words, the SRS is a live document that you will need to maintain throughout the life cycle, or I put it in the terms of the functional safety standard, throughout the mission time of your safety instrumented system. Many companies that I worked with in the past, they have several documents all linked together. Of course, clearly the standard talks about a SRS, but I often see it's multiple documents all linked together. Clearly, the more documents, the more confusing, the more harder to keep it up to date. The more simple is one document because it's only one revision, and that is the one you can maintain easier. So it's like trying to find out what is better. But the ultimate aim, as we say here at the end, is actually to help the people to know what to do, to know how to handle it. Jump on this slide here with the introduction in February 2016 of the IEC 61511, which means the second edition of the functional safety standard to build a safety instrumented system for the process industry. Well, per safety loop, the standard is saying the following, and I want to read this out here with you because I actually copied it out of the normative section, and they say a safety instrumented function shall be sufficient to design and shall include, and here this word as applicable is a very, let's say sensitive, but also a very dangerous word to play with. In other words, many people will say, in my safety instrument function description, I don't think it is applicable to describe the 29 requirements from the standard. And I would say, you are fully right, that could be possible true. However, it is also known that many engineers will clearly say, well, not applicable, because then it's easier for them than actually start to give a background why a certain specific requirement needs to be detailed. Here in this short webinar, of course, we cannot handle all the 29. However, as GMI is helping to educate safety for the process industry, there is this link here to this book, or at least there's a reference to the book, which at the end we will show you another, let's say, copy of the book. But this is the Safety Instrumented System, edition 4. And for those who have the book and who have the edition 4, chapter number 8, on page 223 all the way to page 249, will give you step per step all the 29 items with a practical example.
And Tino, you know, I want to say that I was instrumental in requesting this because from you guys, we never get the right information to deliver the right product. You just get this, you know, typically they say, I want a SIL3 relay or a SIL3 bearing, that period. And, you know, that's not enough information to select the right product. So
it's a fact of life, Paolo, and I think it's also fair to say the first edition 61511 SRS definition of 27 descriptions was out since 2004. That means 16 years ago, we had a good engineering practice. And I can tell you now, 95% of any projects that we visit, assess, or try to investigate or inspect, 95% do not fulfill the minimum requirements of the standard. So it's still a habit. People think they know because they think they don't have to read good engineering practice. They know it better themselves. And unfortunately, it is not always the case. Anyhow, what is the minimum? Well, I start here with the first bullet. What is always the minimum I'm looking for to any requirement specification is what does that safety function has to do from a functionality point of view? In other words, what do you want to measure? A level, a pressure, a trip point or alarm or something like that? What type of interlock or logic do I have to carry out? In other words, if I reach a high level, maybe close the filling line, close the valve, stop the pump, etc., etc. That is the logic. What do we have to actuate as a final element? As I just mentioned, do we have to start or stop a pump? Do we have to open or close a valve? Because safety, it's classically always It's a digital output going on, off, open, close. The only fear we have is when we have to stop or when we have to start, will actually the function be working? And that is where we have some reliability coming in. In one of the next webinars, we're going to give you some more details about that. Then what is very important, which is often not even being described on any safety loop, and I know we have some fast acting processes like in chemical world, we have maybe then some very slow acting processes like filling a huge tank on a refinery. So they all have different concept on how fast your function has to be carried out. And we call this here the safety time, the process safety time. From the moment we measure the hazard is about to happen to the moment we can keep our plant safe, that is called the process safety time. And it's like a rule of thumb for us that we will actually go look at the response time from sensing to final element until we go to the safe state. That time we try to keep 50% of the the minimum required process safety time. And last but not least, of course, we need to know what risk reduction factor do we try to achieve. Again, with a pinch of salt, we have two different opinions here. Some people will work purely with a SIL band. That means that's fine for a quick estimate. But then it's very hard to say, how do we prove evidence that my loop is still performing as requirements, unless you say, I have a requirement to build a SIL 1, but I will go for a SIL 2. That's another customer, let's say, logic that I personally prefer rather than trying to go with a precise number on the risk reduction factor. Additional ones to consider, what kind of hazard does this safety loop try to prevent me to? That's the first bullet over here. What was new by edition 2, 2016? How do I compensate for the bypass that I may actually start to bypass or override an input or a sensing element or a input to your safety function? Assume sources of demand. What type of sources of demand can actually trigger my safety function? Would be very great to have this described in your safety requirement specification, because later on, one of your maintenance engineers or operating engineers may need this to understand what actually happened if he may have, as an example, a spurious trip. He may want to look for what type of demand potentially do we have to investigate. Different model of operation, startup, shutdown, resets. And if you want to have the whole 29 more in details with more examples, you can refer back here to the 4th edition, chapter 8 of the
our book, which you can log in our website, you can view it or ask for your free copy.
Correct. So, some challenges, because it's not always all crystal clear as you already imagine. I mean, or if you already considered or found out yourself, if you read the standard, one of the items here is called MTTR or MRT, and the MTTR is here the bottom one. And let me explain it simple here on this graph on the bottom. You see here the A time, which is the first block over here. That is a time that you will need to find out that your safety loop is not working. You can do two things. You can wait until something goes wrong and then you will find out. Or you can say, no, actually we have a kind of a test regime in our plant and we do something called a proof test interval on my safety loop. And assume that your proof test interval is 1 year, which is 8,760 hours for those who are mathematics specialists. That means you tested the system today, it's working perfectly, you're walking away from it, your plant is perfectly running with no hazard coming up. That means there is no reason that the safety loop would be activated. So in theory, if the loop would fail tomorrow, and let's say your solenoid is stuck open, but you don't know because you're not allowed to move it from the process people, that means the moment that your safety loop is no longer available, you will only find out if it is too late. That means you try to open or close, but it doesn't work, or you try to test it. That's your A time over here. Once you know it failed, you need to prepare yourself, you do your work permits, do we have it in stock, etc., etc. Effective time to do your repair is your C time, and then you needed to take it back into service, do your verification, your assessments, whatever, your documentation, hand it over back to production. So from the moment it fails, that was your B time starting all the way till D time, that is what is called your MRT. And in normal operations, let's say many common, understanding throughout in the industry, the MRTs are typically something between, optimistically, 8 hours, 24 hours, 72 hours, 96 hours. But your MTTR in the old edition 1, that is the one that many people would actually fill in 72 hours. So ask yourself the simple question. If you don't test your system for 1 year, would you feel confident to take an unavailability in your calculation and put 72 hours? I would probably say, I don't think so. But again, I'll let you to think about that, but that's one of the challenges that you will have to overcome. Right. So application program is the last one. The good news is edition 2 has simplified. Simplified in the sense of clearly there is a relation between the logic solver logic with the inputs and the outputs. There's also a close relation to what type of hardware you physically will use for that and what application program. So we used to call this software programming. In other words, in a nutshell, if you program a safety PLC, it's not called software programming, you do application programming. There are certain rules to follow. That also needs to be described not in the SRS by logic, or sorry, by standard. IC 61511 requires us to think about an application program specific safety requirement specification. And again, often that's not the case in reality. So I got a second poll coming in for Paolo.
Distracted again. Let's try this time not to mess it up and to launch the right poll.
No, we're not messing up, we're just challenging people.
So we're talking about SRS, right?
Correct.
Okay, so this is the poll we got on the SRS. So would you consider the SRS as? Oh, we got some answers, you know, design specification document, operational instruction document, maintenance instruction document, seal verification reference document, as-built document, many documents here, or all of the above. Let's see if you guys can do better than the last poll, because the last poll,
was not so good,
you got the wrong answers.
I think it's not. I think it's good that people actually are willing to share what do they think about it, because it also shows they are nothing different than any other ones we have been training over all these years.
Yeah, and you know, honestly, on the first poll, I would have had a hard time answering myself, because well, who is responsible, who have the ownership, responsibility, you know, who makes. We have a question here, if I remember correctly. Let me pull it up. We can answer this question while we wait. It was, I forgot. Something about, you know, who is to do the SRS, you know, and we have answered this. So, okay, so let me see, we have about 70% of you voted. I think we can end the poll and move forward, because, you know, time is not to our favor. So, okay, share result.
Okay.
Okay.
Well, we had 64% voted from the complete group that is online, and from that 64%, 13% in this case, so 45% for those that voted.
45% of the people voted correctly.
Correct, which is actually a good start. Yeah. And I simply say, for those who were thinking it's a design specification document, that is the most common mistake which I hear in my entire, let's say, experience career in functional safety or in safety systems. People think—
without discussing with you before, that would have been my answer.
Yeah, because it's typically common. People say, oh, we use an engineering company and they are delivering the SRS, which is correct, right? But do you think that this document will not be used during the operations and during the maintenance or during the verification? I mean, when I'm making an inspection as an expert judgment, how can I judge without having a reference document in front of me explaining what exactly will be built? So in other words, the SRS, it is all of the above. It will remain initially your design. It will be maintained in your operator and in your maintenance teams. It will be used as the reference document for any judgment for assessments that needs to be made. And of course, it needs to be up to date. So you need to keep it as built, because I'm pretty sure that some of the plans out there within SRS are probably older than maybe some of the equipment, or the equipment has been maybe replaced, not fulfilling whatever was described in the SRS. So it's all of the above. That would be the most complete and correct answer, which I would expect people to do. So thank you, Paolo, for sharing this poll with us again.
You guys are welcome. Let's move forward.
Okay, so as Paolo was saying, on the GMI international website, we do have the SIL manual available that you can request. I mean, request in two options. It's either a soft ebook, which is like a flip book, or you can also have a hard copy. And of course, the hard copy, if it needs to be sent to a specific country, I think the only thing fair to say is here, the book is free of charge, but the shipping, of course, the weight carried needs to be somewhere supported. But the rest, it's a free of charge book, which I do know that Paolo told me earlier, some numbers like 50,000 copies have been issued worldwide. Yeah. So it's a huge investment from GMI to try to help the engineers without taking the pretension that is the book. We are just trying to help you with some, let's say, guidelines additional to whatever guidelines or books or standards that are out there in the market. Secondly, what GMI has done already before the COVID even started, that not many people actually have used, we already had 2017, if I remember well, we had the GMI
2 or 3 years ago, yeah.
Yeah, 2 or 3 years ago, we have an academy that GMI started, webinars, the same as we do now, but they were pre-recorded. So the thing is that there is no questions being asked or polls being done. It's just a topic, and it's the same concept as we do here, except for the poll and the questions and answers.
And you can go on there and see many subjects, we discuss more in detail. So it's a very good academy. We will add to it in time. So
correct. In the list of participants today, I recognized, let's say, a few names, not say many, but a few names that I actually recognized from being trained before. So yes, we still support some trainings. And as Paolo was saying, we can only hope that the COVID restrictions will be soon, let's say, a little bit more flexible, because
we hope in September, October, be able to go back to do some live training. We have requests, Tino, we have requests for people saying, okay, why don't we do an online training when we know that we cannot do an exam online, not allowed, so we have to wait.
We do online training, but not those trainings which we show on this slide. We do trainings here on the bottom, the customized in-house training. I have done a few of them, but the accredit, let's say TOV Rijnen accredited program with a certificate based on a exam is still not possible or allowed online. We can do the training online of TOV, but we're not allowed to take the exam online. So I told myself and also to TOV in the group, I said, it doesn't make sense to train someone this month in, let's say, June and give him the exam in October, because to be fair, after 3 days doing the exam the next day, for many people, it's already a challenge and difficult. If you wait four months to do the exam, I do not want to know what would be the average passing rates. So services, that's the last slide that I want to discuss briefly. We do have all the services on the Lifecycle. We also have the Lifecycle now on the 62443, which is the hot topic. That's called the cybersecurity, which there was just the latest part 3.2 has been released last week or last month, I would say. So this is also out. So this is the ongoing standard for the security management. And by closing, I think before we close, Paolo, we need to do the questions and answers, right?
Yeah, so you just stop sharing and I will share the question and answer, which, you guys had over 80 or 90 registrants and you posed a lot of questions. The one relative to our discussion today, we will show you. So let me do that. We do have some live question here about the course. We said the live course today are not available yet, but we will. If you guys are interested in a personalized course, send us an email. We can provide you with pricing and dates, availability, and so on and so forth. So let me share my screen, my presentation. Okay, let me find the right one. I don't mess it up this time. Okay. Does it show up?
Okay.
We got the question and answer or not?
That is that's the SRS.
Yeah, that's what I stopped share. Okay. I knew I was going to get it wrong.
That's okay.
We had
I have
a bit of sorry?
I have it here also if you don't find it immediately. I've got it somewhere.
No, I have it. It's just a problem that I didn't want to start. Okay, I got it now. Now we had, today has been a crazy morning, right?
It has been.
A few minutes before we started, we had some issues with Zoom. So
I had issues. I mean, it's my fault. I apologize, Paolo, but it was a last second panic. That means my whole setup has changed, but okay, we are online and we can serve the people.
Okay, here we are now. Okay, so this is some of the question and answer we received from you guys during the registration. Let me start. Okay, this is the first one, Tino. It's a bit complicated. Beside the 29 points listed in the standard, do you recommend further consideration as part of the SRS? In example, reliability data sources, confidence factor, maintenance capability, and so on.
Okay.
And this is like you prepare.
Right, so that means I have to say something.
Yes.
Per device in a safety implemented function, what is not directly described in the safety requirement specification is things like the useful life of a device. That means any vendor that you buy a equipment, the vendor liability will actually tell you based on the environment conditions, based on the amount of use, and I'm thinking now about a mechanical wear out of a valve, etc. They will tell you what is the useful life. That means when the useful life is over, you are supposed to replace it with or a revised device or a new device or an as good as new. Basically, simply speaking, the useful life is something very often in the industry not even considered. When I talk to an operating company / an end user, when do they replace a solenoid or a valve? I can give you the answer. When the valve is broken and not working. As long as that valve is working, no one touches it. But fair enough, everyone will use PFD and those numbers to say how reliable this valve is. But useful life, often, don't think that many people has a clear view what useful life on the existing equipment today is in their field. That's one. Second, mission time. Well, the mission time is something that the end user / operating company will decide how long do they want to use that safety loop. Everyone knows that certain systems have a shorter mission time, or let's say a shorter useful life / mission time than what they really want. However, your mission time, preferably, or in theory, should always be smaller than, for instance, your useful life. If your useful life is shorter than your mission time, well, then actually you have a serious problem. Safety manual, and that is the one that I like to highlight here. Safety manual is any vendor, as per April 2010, complying to the 61508 standard, which is now the standard on functional safety for EEPES, that means for electrical, electronical, programmable, electronical safety related systems, needs to provide you with a safety manual if they state that their device or equipment or instrument is in compliance to the safety standard called 61508. So safety manual is not just a luxury, it's a mandatory item to have. Maintenance records. Well, we need to see maintenance records, and what is new now by the addition 2 is how can you prove your consistency of your proof test? Give an example, you have 2 engineers, you both give them the same procedure, they both carry out the same type of procedure in their own thinking or in their own subjectivity. How can you prove consistency throughout your mission time of that safety loop? Then also what is not shown on here, sorry, it is shown at the end, I actually didn't read at the end, the reliability data sources. Where is your fair data coming from? What is the quality of your fair data? Many people blindly take a book from a vendor X or let's say, a public available data source that you can actually privately available. I mean, you need to buy it, but you take that data and you apply it to your plant and you start to believe that data is actually accurate and is actually correct to be used. We are very scared of those type of attitudes. So all this per device beside the SRS is something that certainly I would take into account. And then the SRS is not a standalone document. As I already mentioned in the webinar before, it's an evolving document. Needs to be, it's a live document, it's the as-built key document that will contribute to the successful operation of your safety instrumented system.
So,
Thank you,
you know, basically a lot of information is required along with the SRS, the safety requirement specification.
Correct.
And we had a question, I don't know if you want to answer, might sound in the right time now. It says, during your inspection, you see many times they are not meeting the standard.
Yes.
What are the most common cases here?
The most common cases is that certain, let's say, certain contractor companies around the world, they, as normal, they do like cut, copy, paste, and they think it was applicable for X client, maybe for the Y client it will be also applicable because the client itself doesn't have the competent know-how in-house. So let us give them what they should do. Well, that is very often what is the most common items we see. To be honest, to be frankly with you, we recognize sometimes an SRS without looking who wrote it based on the structure, based on the templates.
Yeah.
It goes without saying.
Document must be one of them, you know, because as I said earlier, many times the information provided to vendors are not sufficient to supply the right components. Okay, let's move forward because time is moving along.
Okay.
So the next question we got was, and it's also a live question we got here.
I saw that.
To verify safety loops. How can we upgrade the existing loop to an higher one?
Okay. And that's probably the same person on the Q&A who posted the question. I've seen that. Well, let me first start with verification. You can only verify against some requirement documents. That means I can verify a loop against a definition, and then I can prove evidence that either that loop is in compliance or not. But it will be purely based on how can I prove that once it was installed, how did we use it, how did we test it, how good was my proof test coverage, etc. Second, where is my fair data coming from, or is that the fair data generic coming from a database? What is the useful life, what is the mission time of that devices? That is all what I will need to verify. It doesn't make sense to spend money and time to verify based on fairy tale numbers. You throw it into a formula, you push the button and you get a report and everyone happy. That's not the essence of doing a verification of your safety loop. Second bullet, upgrade to a higher SIL. Well, I do assume whoever asked that question, you may need to, or you probably mean you want to go from a SIL, let's say SIL 1 to a SIL 2 as an example. Now,
that is a correct question.
What I'm saying in here is, in the first bullet, assume that you have a safety loop in the field with an existing target risk reduction factor, which was minimum 200. That means it's in the beginning range there of this SIL 2 band, right? Because SIL 2 starts on 100, goes to 8,000. A SIL 1 starts from a 10 to 100. So it's like on top of each other, a SIL 2 between 100 to 1,000. Assume that my target of my loop was 200. But my safety specialist team comes back to me and I'm the instrument guy. They say, you know what, Tino? There is no money to replace any equipment. There is no money to buy some different equipment with a better performance equipment. But the target in our discussion needs to go to minimum 575. Let's say about halfway in your SIL 2 band performance. What you could consider is you could increase two things. Either you could increase your proof test interval, where maybe with the 200, it was decided you could only test every 18 months. So maybe you will swap this and say, now we're going to test maybe every 10 months as an example. Or you can try to improve the proof test coverage. Maybe in the normal circumstances, like many other clients, you may not be allowed to test live on a production unit. You have to first shut down the unit, and then you have to take a coverage as per a simulation, which is of course always very difficult and also subjective. That's one way. Assume that it's different. You have a design requirement risk reduction factor of 689. So somewhere you're already at the 70% of your SIL 2 band. And your safety specialist tells you, actually, we need 1,450. In other words, you are moving from SIL band. Well, then very clearly, whatever magic you're going to do on increasing your proof test interval or coverage, I call it magic, let's say, whatever you try to increase by coverage and also by factors will not work here by the simple fact that your minimum architectural constraint will be changing to go to a SIL 3. So it's not just on paper possible to do it, And that's the two examples or the two answers which I can imagine. One of those two is based on what's your problem, why you ask this question.
So to summarize, Tino, if we're moving within the seal band, harder than replacing with different components, you can play with the T-proof time.
Correct.
So shorten the T-proof time intervals.
Correct.
Or improve the test effectiveness. So test more, a better test. Whereas when you jump from one seal to another, you need to verify that the entire loop is complying. So every component has to comply with the seal level that you're trying to achieve. Maybe you bought a seal 2 transmitter, now you want to use a seal 3 application. Well, you cannot do unless you, as you said, you go to a different architecture.
And
it's more complex.
Also, yeah, Paolo, I just want to add this. Your previous webinar that you have done together with Mauro on the 61508, 61511 was tackling this topic also. The devices is not just a seal number. There is more than just a seal number to look at.
There is also systematic capability.
Correct.
All right. So next question was, what are the standards for safety loops? Well,
that's a good question.
You know this answer, if your guys are here.
Well, unfortunately, there are too many to list. So what I've done is I try to give what my personal opinion is. 61511 is a good engineering practice standard. A good engineering guideline saying how can you design, operate, maintain, etc. a SIS for the process industry. That's the first bullet. However, assume that I would only use that standard. I can tell you now, you will never be able to build a plan and to maintain it because there are too many different application-specific standards, which is the second bullet, which unfortunately for you and I, they are not often in line or compatible or even talking to each other or even liking each other, to be honest. So in other words, you have many application dedicated standards like the ones for fire and gas, BMS, or whatever is listed over here, but they are all dedicated to one specific application, whereas the 61511, they have this wide umbrella called process industry. But in all the process industry, there is a burner, a boiler to make some steam, or there is a fire detection system, or there is a gas detection system in some plants, and they have also their own dedicated application-specific standards. So I was first thinking, let me give them a list here of all the NFPA and all the different standards that I come up with, but even when I tried, I thought it's wrong for me to say numbers in here because I'm sure I will even miss out some of them. So in other words, be aware, 61511 is only a generic engineering practice for the process industry, but you will have to add up also all the additional application-specific standards complementary to the 61511.
I would say, Tino, all the applicable standard to your industry, to your application, needs to be applied on top of the 61511.
And as I said, sometimes it could be a conflict. In some cases,
sometimes they're in conflict. This is true. Okay, well, the next question, I believe we already answered this question in our presentation.
Yes, that's good.
We had a poll for it. Is the SRS development the responsibility of the end user or the integrator? Well, guys, without showing the next slide, you should know this by now. We gave you the answer already, but it's more detailed. Who is responsible for an SRS? If you want to run it quickly,
Yeah, the responsibility is different than the ownership. Okay, so the SRS described the SIS functionality will be achieved or will achieve a certain risk reduction factor. However, the second bullet here, as we mentioned in our poll in our previous slide, it's always the plant management, plant owner, operating company, end user, whatever you call them. They are actually responsible for maintaining the safety in that plant. And that's why we set the ownership of that document lays on with them. But, and this third bullet is an important one. Therefore, Mr. End User Operating Company, they need to select a competent person / department / company that will help them to define and develop and also later to maintain that safety requirement specification. And in closing, I want to highlight this, and there is another webinar coming up. It's not this week, it's one of the coming weeks. So if you go to the website of GMI schedule, you will see it. but look for the functional safety assessment. Then I will go a bit more in depth on the stage 1. Stage 1 is a normative requirement by the 61511 in the life cycle that an expert judgment by a senior competent person, not involved in the design team, shall judge that the SRS is actually being accurate and is actually being complete, etc. He needs to make his expert judgment on that. And that is why it is a must to carry out stage 1, which is right after, before you issue your, let's say before you start to design and build your physical system and your SRS is ready to be sent out. Well, that is where we want to see that stage 1 assessment be done. Okay, Paolo, thank you.
Okay. Well, next one, which preliminary method is more effective for the development of an SRS between risk graph and LOPA? And I believe there was a question live here that said, what are the differences between ASOP, LOPA, and so on? Maybe you want to answer to that also.
Okay. Well, let me first stick to the question that is shown here on the slide. An SRS based on a risk graph, to be honest, is a lot more quicker. So for some people, you'll call it more efficient than, for instance, trying to do a LOPA. What is LOPA? That's more an in-depth analysis on frequencies, on numbers. That is where more discussions are possible. Whereas with a risk matrix and a risk graph, it is a lot faster because it will say, we have that type of frequency, we agree with that in the group, we have that type of consequence, we agree in the group also. The risk matrix will tell you still 1, 2, 3, period. That's a very quick approach. Now, with that approach, the disadvantage will be that, let's just assume that the risk matrix or risk graph was not, let's say, very clearly being defined and is subjective. And the team the next day that is coming in takes the risk matrix and they all agree with each other on that moment of time and said, oh, we take a still 2. But actually, when it was defined, the consequences for that particular frequency potentially in the field was actually not enough to cover it with a SIL2 risk reduction factor. So in other words, my advice would be, if you would go for a quick risk graph or risk matrix, that's nothing wrong with that, but try to be conservative. In other words, if your team agree initially that it can be covered with a SIL1, why don't you try to build a SIL2? So you go 1 SIL band higher. That means whatever happened in the future, you always have a certain margin that you protect you more than actually initially needed. Of course, you can say, yeah, but that is costing more money. Well, I do know some customers that is their standard approach. The risk matrix is calibrated in the sense that initial team said we need a SIL1, but they will go for a SIL2. And I like that approach. But of course, that's not good for your budget and for your, let's say, project cost, etc. Opposite, you go to LOPA. Benefit is LOPA, it's precisely giving you what risk reduction factor performance do I need. However, it does not give you, let's say, the feeling that when you go with a number, the question is, where is that frequency coming from? And when you start to debate that in any team, how do you agree with each other? What is the likelihood that a hazard will become a risk? And some people say, well, we think it's happened once every 100 years. And the other one sitting in that team saying, hang on, guys, we don't have budgets for once every 100 years. Let's really think about that. Until everyone said, oh yeah, I think it's only happening once every 10 years. So what you have done is you just gained 1 SIL band performance by just talking about it again. So when you are in that LOPA discussion with this frequency, that is often the fear that people start to play with number to suit their budgets. That's, of course, also not the essence of the standard. And then the quick question that Paulo mentioned, what was coming in the Q&A. What's the difference between PHA, HAZOP, LOPA, SIL? I don't even know what ILP, probably independent level protection. I'm just imagine or assume something here. But anyway, how do they fit in the safety lifecycle assessment and lifecycle? Well, all of them you mentioned, all of them except LOPA, they all fit. Well, no, it's not true. PHA and HAZOP, they fit into phase 1. That is your initial phase where you do your hazard and risk analysis. We call it the PHRAs. Your LOPA is already the step after. That means you already know what hazard, you already know what frequency you're going to have. And there you're going to think about existing layers. What is my LOPA capable to reduce, yes or no? Your SIL is coming out of either one. So that could be out of phase one when you use a risk matrix or a risk graph, or it could be out of the LOPA. And then I have to apologize, I do not know what ILP would mean in your definitions. So they all fit in the life cycle in the beginning, but they have nothing to do with this webinar here on the SRS because they have been done.
Tino. So let's try to get to our answer before we run out of time here. So can a SRS specify a SIF using new FE, which stands for, Tino?
Final element.
Okay.
I think
redundancy with all the system one. If yes, how such case can be treated and past lifetime on existing final element be considered? Wow, that's a tough question.
Okay.
All right. Let me see your answer here.
What I've done is these questions which you show, I copy paste them out of their registration form. So I did not try to add some names or text difference. So the FE stands most likely for final element. So an SRS will define the SIF architecture based on the minimum architectural constraint. In other words, when I do know that my team has requested me to build a SIL tree loop, I know I cannot do it with one single valve, period. Why? Because there, the architectural constraint from the standard will ask me to follow either road 1H or road 2H. Again, that's very specific. That's coming out of the 61508/61511 architectural constraint. So, to answer your specific question, an existing loop using a final element, a single final element, that is my assumption here, okay? That's the second bullet. Cannot be required to add redundancy unless your SRS specification was wrong in the first place. In other words, assume that someone told you, oh, you have to put an additional final element on top of, or in series, whatever it is, is it a fail to close or a fail to open, depends on what is your safety function. Assume that this is a fail to close, so that means we put a second valve in the same line with the other valve to have a 1 out of 2 valve. Well, if that is the case, there must be a reason for that, because you are increasing the hardware fault tolerance, you're also most likely going to a different SIL band, etc., etc. In this case, or in that case, the SRS will have to be modified. And then every single lifecycle activity which could be affected or has an impact will have to be revised and revisited. And then what do I say here at the end, which I mentioned already in the webinar? Use your full lifetime of the final element. Useful lifetime of the final element and the mission time of the final element. Those two will determine when that final element will need to be revised or overhauled or be replaced with a as good as new, identical in functionality final element. Thank you, Paulo.
Okay, well, I was tapping away some answer that did not require a live answer. So next, what are the must and mandate points that can be compromised in SRS report? I guess the question means included in the SRS report, right?
Correct.
Because compromise means something else. Okay.
So, of course, you are asking it here to the devil's advocate. That means that when we are doing assessments and inspections, we are taking our guidance, which is the 61511, and then the inspector, and I'm reading, you shall describe and you shall include. So if you could convince me on one safety loop why you shall not do it or you shall not include it, because it is your full right, because the standard said as applicable, you can say, Tino, it's not applicable for us to describe this. And if you can convince that on any assessment or any inspector or expert judgment, and you can have a case that you can document why you don't want to describe that, that is possible. But I can tell you, the excuses why not to do it are a lot cheaper than the real reasons why you should do it. In other words, clearly, our aim is to try to describe it as detailed and maximum potentially as possible. Of course, that's subjective for most engineers. They typically think they know it better. That's a normal way. And I'm one of them also. I always think that maybe I know something, but then it's proven that maybe it was not correct. As Paulo was saying, the last second panic was that I prepared 20 minutes before the webinar, and the moment before we go live, my app was starting to giving me trouble, so we had to do some reboot. And anyway, long story short, it's clear we as a human, we think we have certain ideas about certain things we have to do, but they may not be in line to what a good engineering practice expects us to describe. And I'm saying purely the following sentence. Take one example of one sieve loop. Take the example that we described in the SIS manual from GMI and try to judge for yourself, why do they describe this in the GMI book? Why did we not do that in our? And then ask yourself the question. Maybe we think in the GMI book, that's an overkill. We don't need this for us. That's possible. It's not me to judge that. But we have tried, we have given you some, let's say, practical, let's say, examples on what is supposed to be in there. So a must is a strong word because the 61511 is a normative requirement. It's not a law. It's a normative requirement. You know when it becomes important? When something will happen in your field. When the investigations is coming in and they start to investigate in how good your documents were being describing what should have been built, what should have been designed or used or maintained, etc. So what I propose here at the bottom is, I propose to use a generic template for a SIF. Yes, even I would propose per client a generic SIF template. And there are some common requirements for sure that you don't have to re-describe every time again and again and again. So in other words, from a generic template, you will have some common sections for process units, which will be not repeated on every single loop. But the minimum requirements that needs to be shown on that safety loop in order to prove evidence that the loop is working as per design, those are the ones that I need to have been described in real detail and not tell the engineer in the future, go find yourself the answer, talk to people, find books. No, the SRS should be his guidance on what and how it should be done.
And you know, Tino, let me bring my experience as a vendor when we had to replace several thousands of relays installation because the requirement said we want a SIL3 relay, if I remember correctly, for a certain type of loop. But you know, there's a big difference in the safety function, what this relay is trying to achieve. You might need to open or you might need to close something. And they are designed in such a way that one is opposite to the other. So if you select the wrong relay, instead of being SIL3, you are, I used to say SIL -3. You better use a normal relay than use a safety relay that is wrong in the application. So this, you know, this is why we stress so much about SRS. It's an important document. Maybe not all 29 points are applicable, justify that, but at least try to describe the minimum.
Okay.
All right. Yes. Next, we have one more question here that was registered, and then we have a couple of live questions. Let's see if we can get to them. How to divide complicated function having common execution algorithm and multiply IOs, for example, sensor or control equipment unit into SIFs.
Okay.
All right. This again is not really pertaining to our SRS seminar, but let's see.
More or less. Okay. So I would say, regardless of a simplex or a complex architecture of any safety loop, your SRS shall describe exactly how that SIF needs to be configured, built, maintained, etc. So clearly, if you would have a complex loop and you have multiple I/O, some common sense comes into play also, which the standard will not tell you. I'll give you an example. Assume that you have a redundant safety PLC from brand X. And the redundant safety PLC has two different I/O modules, input modules. You have two sensors in the field that needs to measure a 1/2 measurement out of a certain process variable. Well, it would be very wise and logical to hope that the engineer that is doing the hardware assignment of these loops will use two independent modules, as an example. Meaning that, logical thinking that if one module would be failing, well, we still have the other one. But I know some other, let's say, design, let's call it limitations / sometimes mistakes. People take a redundant I/O module or a triple redundant I/O module, and they have, for instance, 36 channels or whatever, or 32 channels, and they wire those 2 out of 3 transmitters, ABC, on terminal 1, 2, 3. Well, is that very wise to do? I would say most likely not. But assume that you only have 10 signals. I don't assume you're going to buy 10 different cards to be diverse in your hard wiring also. That's one thing. Secondly, I assume that the complex algorithm is based on what I just explained, a safety PLC. That means the safety PLC itself may have a certain architecture, may have a certain redundancy. Clearly, they also have always some potential common mode problems and common cause problems. And between a common mode problem and a common cause problem, although we don't have a webinar on it yet, but there's also a huge misunderstanding in people's mind. For me, a common mode problem is always a design/human error in how they designed it. Otherwise, a common mode would not exist. So common mode would be, for instance, when I have this one module failing and I got these two IOs on this one module, well, I would not call this a common cause problem, I would call it a common mode problem because you designed it to go on one module. That's one thing that I would like to say. So common cause is more related for us to the environment in the field. Assume that you have a earthquake, you have a tsunami coming in, you have a flooding in your field or in your plant, and you have those two sensors are both affected by the hazard, which is here the nature. I would call this a common cause. That is why you're going to judge on your estimate, your beta factors, what is the likelihood that some sensors will have the same failure based on the same common cause failure. When possible, try to be, for the critical complex shifts, to use diverse and independent I/O to minimize those common modes/common cause problems. I think that's the last question, Paulo, if I remember well, correct?
There was a question that said, how can I get more knowledge regarding IAS and functional safety? And let me say, we have many webinars live. You can go live webinars as well as all the webinars are recorded and eventually published on our YouTube channel. So you can go there and review them.
I got some...
Now we have some live questions. So let me see if I can do like this. Stop share. Here we are. New Tino, we are about an hour, but still people are with us. Let's see if you want to answer some of this.
Sure.
There was a question that's a little different. It was talking about cybersecurity training. Are they based on ISA or TÜV Rheinland?
Well, it's clearly the ISA is having the foundation based on the ISA 99 is now the new standard called the IEC 62443. That means the reference document for the training is used is called the IEC 62443, but is managed by the ISA as a reference document. That means any company out there referring to a training 62443 is actually having their own, let's say, way of teaching. The TÜV Rheinland clearly is using the same source document as our, let's say, colleagues in the ISA, but those training programs are independent from each other using the same reference document.
All right, there's one more long question here. It says, on multiple similar trains that are exactly the same, so same design, same device, and located in the same site or different site, how the SRS verification is implemented and documented. That could save time and cost without compromising safety. So, is it clear, the question, you know?
It's clear, and it, I mean, there are many questions I can ask, but I would say you have a similar production train. As an example, you have an LNG train, and the LNG train is, for instance, somewhere in Africa. The other LNG train is somewhere here in the middle of Europe, and the other train is somewhere in the middle of a very high population area where a lot of people are living around. So one is in a desert.
So very different conditions.
Correct. They will have different conditions, although the production unit is the LNG train, but let's say your risk criteria is changing. Therefore, depending on, remember who was responsible. If this would be all the same end user / operating company, they will have a corporate tolerable risk, which is the same for all the plants. But assume this one plant from the same operating company in this dense, let's say, population of people living around it, they may have...
Where you are, there are so many.
They may have to do more risk reduction than the same company with the same train in the middle of the desert. So it's a very hard nut here to give you a clear answer. I'm trying to be very open with you. It depends on so many factors. The framework of the SRS may be the same, but the architecture based on the SIL or the risk reductions may be totally different for the same plants, the same productions in different areas.
Right. Okay, there was one question here that I kept for last. We still have a few moments if you guys want to stay with us. It says, how can I do a C study for a process train?
That's, well, yeah, it's like, how do we build the city of Rome? Well, first you select...
Exactly, this is exactly the question.
Okay, serious, okay. How do you do a SIL study? Well, that's a good, valid question for someone that would have maybe never been involved in such type of study. But let's start from scratch. The first thing we will have to do is we will have to think about what type of production unit, what is my tolerable risk, what are my potential risk criteria, and based on this, we will come up with a certain requirement, okay? So your SIL study, I'm talking about SIL study from the beginning. You could also mean, how do I do a SIL study of an existing plant? That means I will have to collect some behavior, some data, some test records, which is a whole different story. So again, SIL studies, people talk about a SIL study, well, what does it really mean? You study, do you want to prove with a verification? Or do you want to determine what needs to be built? Those are all kind of SIL studies, different in where in the phases of the life cycle you are. So it's not, let's say, clear for me what is the intention background of the question to give you a very good answer. So I try to answer as flexible as possible.
I think we've done a pretty good job. Let's see, we went over our time. Let me relaunch the poll, which I mistakenly launched earlier. Let's see if I can do that. So then you guys, you can give us a feedback, see how we did. Me and Tino, of course, it's bad answers for Tino and good answers are for mine. All right. Well, okay. So, and keep in mind to look out for our next webinars. Just log in gminternational.com and you can see the live section there. There's many. Okay, great. Let me end this poll and share the results so you guys can see. Most of you said excellent. Thank you very much. And thank you, Tino, for being with us today.
Thank you.
Excellent speaker. Your experience is unmatched. We shall see you again very soon, I believe next week.
No, next Thursday morning early, we have function safety management.
All
one
right.
of my
So
favorite babies.
You're welcome to register again. Ciao, Tino. Ciao, everybody. Thank you for joining.
Okay, thank you.
Thank you. Bye-bye.
Bye-bye.